We want to take a robot and have it be able to navigate through an environment kind of like a human can. We kind of focus on here our two main sensor types: cameras, using vision just like a person would use vision, and another sensor called a laser scanner, which essentially shoots lasers out into the environment and then measures the distance that each laser takes to hit whatever it encounters, and then kind of builds like almost like a 3D model based entirely of little points of the surrounding environment. A lot of people have been successful in building maps and navigating using these kinds of sensors. But what happens is when you go out with a camera one day and you take pictures, when you come back later, it'll look completely different. The lighting will have changed, the cars will have moved, people will have moved, and even like if you want to use a map for a really long period of time, the seasons will change and things like that. So the specific thing we're working on with the Segway project is to be able to build maps that last a long time. You can keep updating over time, and they're robust to visual changes in the environment, like lighting, and that's the project. So I have an Xbox controller. This drives it. I walk behind it and make sure it doesn't go off the curb, doesn't run into people. Like kind of like a dog, right? Like, yeah. This is the DGPS antenna. So it's a differential GPS. It's a really highly accurate GPS that we use for ground truth, to tell if the algorithms are working. We have a Ladybug omnidirectional camera. It has six different cameras all arranged so that it captures the image pretty much of the whole hemisphere around the camera. This is the Velodyne 32 laser scanner. It has 32 lasers in like a vertical configuration. In every revolution, it collects about 1 million points. So you have lasers like this, and as they move through the environment, they sweep out the environment. So about 1 million points a second it collects of 3D information.
I want a coffee. Where do I put the dollar?
Yeah, it doesn't fetch coffees yet, unfortunately.
All right, thank you.
Yeah, no problem. We're taking the data that we've collected, and now we want to process it to build a map of the environment. And so here's kind of what the robot sees as it travels from the laser scanner.
So how does it combine the laser scanner with the point map?
Well, so we have this like calibration procedure, so we can take anything in the image and map it to the 3D data, or we can take anything in the 3D data and map it to the image.
Huh.
And so this is all the 3D points that we've collected, or a subsampling of the 3D points, because otherwise it'd be like billions of points. And this is the inside of the Duderstat that we passed through. You can see from the top down, you get really like a floor plan almost, right? But then it has the 3D information. You can see the pillars, and if we go inside the diag, you can see that's the clock tower kind of in the foreground. Next step is to take the 3D structure and then overlay the imagery on top of it. The idea is maybe not a robot, but an instrumented camera, whether the instrumented camera is on a car, in a cell phone, and those can be able to use this map.
That's awesome.
Thanks. It's North Campus, so most people say it's awesome. Yeah, people jump in front of the camera. I got some funny pictures of them. Wow, that's cool. When's it going to take over the world? You know, stuff like that.